acid. So this is all base. And this is all. So that's our pH scale that we're looking at. The first thing that we're going to do when we go down through here is we're going to talk about the levels of pH, and this is just to get us familiar with the pH of everything. So sorry for the crowded room, but that's we can do on that. So we're going to look at what is the pH of the 7 different things. So we have 2 stations. You guys are going to have to divvy up. We have this station, and this one, and that one. So how we're going to measure the pH is we have pH paper, and we're going to get the pH paper out. And then you just tear off a little strip. And then you're going to measure the pH, and then you're going to test it against the colors here. These different colors tell us what our pH is. So we're going to test a couple of different things, and you're just going to take a little strip. What's the first one on the list there? Vinegar. So do you think vinegar is going to be an acid or a base?
Acid.
Acid. We know it's going to be an acid. So we just take our little strip. Normally we put these in little beakers. And we're going to test the pH today. And then we're going to put it up against our paper.
It's an OH, so it's basic.
So it's really acidy. The next thing is skim milk. Where do you think skim milk might come in? Acid, base, neutral?
Basic.
Basic. It's actually slightly acidic. Right. Yeah. So it comes in at pH of 5. So just write these numbers down as we go along. Then we have apple juice and grapefruit juice. How about juices? Acid or bases?
Acid.
Acid.
Weak
They both
acid.
come in around 3. Write that down. Coffee, acid or base? Acid. Acid, because how's it feel on your stomach? Sometimes you're kind of like, it's kind of hard, right? It's a pH of 5. What about milk of magnesia?
Basic.
Base, yeah. So when we take our paper and we measure it, we take another piece and we measure that, that's the only thing that's going to be basic in this lab. And that's often a test question. And we have 4 different labs that we're doing here. The first one, when we tested our products, which one was basic? And this is the only one that is. Yeah, so it comes out to be 9. Well, what is milk of magnesia for? Mylanta, acid. They're antacids. Yeah, neutralize. So that's what we're going to do in this lab. Is we're just getting an idea of what everyday pHs are, things that we might consume. Then the last one, tap water, should be neutral at 7. So that's going to be our baseline, tap water 7. Then, so what we're doing is we're just getting kind of an idea of everyday items of where they are, acids or bases. So the only thing we did that was basic was milk of magnesia. And we use that to buffer, to neutralize the acids in our stomach. So what we're going to do in this lab is we're going to learn about buffers. We have to be in normal pH of 7.3 to 7.45. And how are we going to buffer? How are we going to stay in that range is what we're going to do in this lab. So the next line below there, line number 1, says rank these in order of lowest pH to highest. So you can just, in your mind, do that. So lowest pH would be acid, correct? And highest pH would be base. So you can go through and rank those. And you're just getting in your head an idea of where are we on the pH scale. That's what we're looking at there. And then the next question asks you the same question, but in a different manner. And asks you which is most acid and which is most basic. So same question, we're just getting you familiar with terminology. And then the last last one says highest hydrogen to lowest hydrogen. We're asking the same question, just in 3 different ways. So what would be the highest hydrogen? Which one would that be?
Acid.
Vinegar, right, so the most acidy. So we're just getting you familiar with the terminology. Low pH is acidic. If we're from 7 down to 0, that's acidic. If we have, the more hydrogen ions we have, that's acidic. We're just getting you familiar with the verbiage. Questions over that part? All right, now we're going to move into the buffering part. So we have to be in the middle range there. And when we're looking at pH, we have several ways that we can buffer in our body. The first one is we have 3 buffers. And this is what we're talking about in the lecture today. So if you feel like we're going a little fast, we're going to repeat it in the lecture. So we have chemical buffers. And the chemical buffers are going to be fast acting, but they're going to be short term. So they're not going to fix anything, they're just going to neutralize temporarily. And the 3 that we have are bicarbonate. We have the phosphate. And we have protein. Is protein abundant in our body? Yeah, it's very abundant in our body. So that's what we're going to do in the lab here, is we're going to use protein to act as a buffer in this second experiment that we're doing. All right.
Oh, shit.
A bug. Okay, so experiment 2. What we're doing is we're going to do 3 experiments where we're not in range. And we're going to buffer them in 3 different ways. The first way we're going to do it is a chemical buffer. And the chemical we're going to use is protein. So we have protein powder that we're going to use. In our body, we have lots of protein. So it's going to buffer all the time. So experiment 2 says, question number 1, pour 90 mils of water into the beaker and measure the pH. So we already decided over here that water's pH is 7. So write 7 down for that. And then we're going to add 10 mils of milk of magnesia. We know milk of magnesia is pH of 9, so write 9 down for that. And then the fun begins. So now you actually have to go over to our one little sink. We can go into the next room and get water too. We need 90 mils of water, and we need 10 mils of milk of magnesia. And we're going to put them into your beaker. So use your beaker, get 90 mils in there of water. And then use your graduated cylinder and put 10 mils of milk of magnesia in there.
You did.
And we're going to dump them both in the
I had a little bit of a headache.
Yeah, but just
I won't be
bring
even.
the milk of magnesia and the tall thing and the graduated cylinder. So you guys need to divide up into 4 groups.
Yeah, I think it's just.
So everybody get into a group. One group's here, one group's there, one group on this side, one group on that side. So you need 90 mils of water in your beaker, 10 mils of milk of magnesia in your graduated cylinder.
90 mils of water.
Do you believe this is your beaker, that's your cylinder? This doesn't have a clear marking.
No.
Oh my goodness. 10.
A tiny bit and you put in at the very front inner part and you put
Triangle, so we don't have any So what we
There's a reason that one's a little longer. Is it good?
Nate.
Yeah, sure. Is it good?
Jesse, where's the beaker?
I was gonna rinse it out.
nauseous, because when you look at that, made me a little nauseous.
Next week.
Monday.
You said I go to work on Monday.
Why are you always stuck with that?
Wednesdays is when I'm moving.
We still ain't back yet. Yeah, you're right, and you have to
So it is ours. You have to do it, right?
recognize the video traffic.
For next.
Oh, you wanted?
So,
Do you want to wait now?
so when you have your 10 mils of, 90 mils of water, put that in your beaker. So we're on line number 2A. Water is still the same, it's still at 7. And then to the water, we want to add 1 teaspoon of our buffer. And the buffer is protein powder. And then measure that pH.
Did you measure it?
If you already put the milk and magnesia in, then that's fine. Just hold tight for me. So put your 1 teaspoon of protein powder in your water. And then measure what that pH is. And you can stir it later.
Right, we need that and we need that pH right now. And then we need the protein.
But it's not already
10 milliliters milk of magnesia.
Yeah, go ahead, put your teaspoon of protein.
2A says the measure.
Yeah.
Okay.
Yeah, we're not on that way.
So for 2A, you should have 7, because water is still 7.
No, we are home.
For 2B, when you put the protein powder in the water and you measure it, the pH should be about 6.
Wait.
So we know that protein powder
Sure
is
you did
around
that.
6.
Yeah.
So for 90 milliliter water, at 1 level teaspoon protein powder.
So 2B should say 6.
No, we gotta do this first, because we got that right. And we gotta get 10 milliliters. So,
And then add everything together.
Well, it says here, carefully discard solution.
Add everything together. And then measure your pH. Put a teaspoon of protein powder in your water.
Yeah, see, look, it says here, carefully discard solution, because we already have that. We already did that.
okay,
So
It's
we
gotta
just
be
did the
level.
protein.
it's gotta be level.
1 teaspoon of protein powder to the water, stir and measure.
Use those strips to
So we don't need that.
Just like, they get followed around the.
Yeah. Swap around and.
They'd be like, oh, your water's broken, or like, okay.
I don't know, because the vaginal lining is slightly acidic.
Yeah.
To kill these things. So I would think slightly acidic.
I have no idea, I watched them do it, and I was like.
They do it with my nose. Mine is something next to it. So it should be 7 hours or natural.
It'd be harder with. Got a little more in there.
I.
It's getting there.
It's getting there.
So you said
So it should be about 7 or 8.
So you said bakery? For which one?
Looks like 6.
9, 7, 7, 6, 7.
Alright, so let's go over our numbers. So what are we doing here? We're using, we're looking at an example of a strong base, and our strong base is milk of magnesia. It's at number 9. So we put water in a beaker, that's 7, that's neutral, that's 1A.
Now we put the milk of magnesia in there.
Everybody listen and write these numbers down. We have to stick together on this lab because it's pretty complex. 1A is 7. We measure water, or we measure milk of magnesia, 1B. That's basic, so that should be 9. And we know this is the thing we're trying to buffer. We're trying to get to about 7. We're trying to get back to neutral. So how we're gonna buffer that is we're gonna put the protein powder in. So 1A, we're just getting ready to put everything together. Water in the beaker is still 7. In 2B, protein powder should be 6. It's a little bit acidic. And then when we mix a strong base with a buffer, it's gonna shift that back. That 9 is gonna come down towards 7. So we just buffered it. And how we buffered it was with our chemical buffer protein. So we were up here at 9. We can't have that existing, it's too basic. So we buffer with protein and we come down to about 7. So that last number should be 7 on 2C. So see how we took a strong base, 9, down to 7. So we buffered it, we neutralized it. That's the same thing we're doing when you have heartburn, hydrochloric acid, it's pH of 1. And we get that hydrochloric acid in there, so we take a Tums, milk of magnesia, Mylanta, whatever you take, and you neutralize it. That's why it gives you relief. So in this experiment, we had the strong base milk of magnesia. We used protein to buffer it, and we came back down to neutral, down to 7. So that's pretty cool, isn't it? We're going to see how it happened. Now the chemistry behind it says protein can act either as an acid or as a base. So that's the cool thing about protein. However they need to go, they can act as an acid or they can act as a base. So if we're too acidic, we can use it to bring it up. And what we're going to do, that's what the picture is showing you there on page 91, or whatever page it is in your book. So remember our basic structure looks like this for our amino acids. And then we have a hydrogen out here. So it's going to act as an acid or a base, and what it's going to do is if it's acting to add this hydrogen in there, or it's acting to liberate that hydrogen. That's how a protein, which is made up of amino acids, that's how a protein does it. It holds on to this hydrogen, or it gets rid of that hydrogen. So it allows it to act as an acid or a base. So in your picture there on the bottom, it says, what would it look like if the amino acid was acting as a base? If it acted as a base? If it acted as a base, we would add that on there, and then in your picture, you would have NH3 up on top. So between H3, C, H, R, C, O. So we can add it in, and then it goes to NH3. That's how it would look if it acted as a base. Because remember, bases are proton acceptors. They don't have enough, so those.
Okay, there you've got your R group. Carbon with the 4.
Yeah, if it acted as a base, then that's what would happen. But that's not what we did in this experiment. Turn the page, what we did, or maybe it's on your same page, what we had on top of the next page. So in this situation, we acted as an acid. We took this hydrogen, and instead of being basic, we took that hydrogen, and we gave it up, so we have another hydrogen. And we went from 9 down to 7. So we were acting as an acid, right? We didn't get more basic. We didn't go from 9 to 11. That would be acting as a base. We went from 9 to 7. So when we're going down the scale, we're going in the acid range, correct? So in the situation we just did, protein acted as an acid. And this is what happened in our picture. How did it act as an acid? It gave up that hydrogen. And we liberated it. The more hydrogen we add in, the more acidic we become, right? So in this experiment, we acted as an acid, and then this is what your box should look like. So you're not going to have to draw pictures of this on the lab test. What they're going to ask about this experiment on the lab test is experiment 1, which thing was a base? Milk of magnesia. Everything else was an acid. When we measured
Oxygen.
Experiment 2,
With an LH.
what did we use as a buffer? In the experiment of milk of magnesia, what did we use as a buffer? Protein. How did protein act in that experiment, as an acid or as a base? As an acid. Because we were at 9 and we went down to 7, so we know we're going in the acid direction. Right? And then on the next page, so which direction did this, which way did this reaction go? It shifted to the left. It went down the pH scale. And an acid neutralizing reaction. So the reaction. You went from 9 to 7.
If you didn't add enough protein, you wouldn't get down to 7.
And then just take some more, and then it's gonna take it further down. So that's what we did in this one, where we were buffering. We were buffering a base. The base was milk of magnesia. It was at 9. It's too strong. We can't exist there. So we're going to use one of our ways that the body buffers, and that's a chemical buffer. The chemical we use is protein. What we used in lab was vanilla protein powder. And it took it from 9 to 7. So we went from a base to an acid. So the protein acted as an acid, and we shifted left. On the pH scale, we shifted left. Make sense? All right. So go dump out clean out your cylinders and your beakers. And then rain goes back. All right.
I have to copy this from you.
Okay.
I'm gonna pause that. I ordered my 64 gigabyte memory card.
Good deal.
I just haven't gotten it yet.
I don't need to know its molar mass. Caustic soda. That'd be acidic. Pretty soluble. Really? Honk. You'll see regret it. There's a highly caustic metallic base.
Yep, go ahead and take it. So the third experiment we're going to do is we're still buffering. We're still going to be in an acid or base situation, and we're going to buffer that. So now we're moving into the second and third kinds of buffers. First buffer, chemical buffers, they're short term. They're going to take care of the problem, but they're not going to fix anything. We're going to take a Tom's or an antacid or whatever. But why do we have heartburn? We need to get to the root of the problem, right? So then we switch into what we call physiological buffers. We use the chemical buffer, protein, in the first one. Now we're going to use physiological buffers. And we're either going to use the lungs, the respiratory system, And anytime we're using the respiratory system, how it's gonna act as a buffer is with our breathing. So we're gonna breathe quicker, or we're gonna slow down our breathing. And what we're doing is we're getting rid of carbon dioxide, or we're holding on to carbon dioxide. So the second buffer we have is the respiratory system. And how it buffers is by what we're gonna do with CO2. CO2 is an acid. And we're gonna blow it off. If we're too acidic, we're gonna blow it off. We're gonna increase our respiration and blow it off. Or if we're too basic, we need to come back down the scale. If we're too basic, then we're gonna hold on to our breathing. We're gonna take slow, steady breaths. We're gonna accumulate CO2 and drive that back down to neutral. Does that make sense? Okay, so that's the experiment we're gonna do now, is we're gonna simulate the lungs. We're gonna use the lungs to buffer something. All right, so it says in experiment 3, we're going to use the role of the respiratory system. And what we're going to do is we have the little blue vials or beakers and little blue or brown bottles. Has an indicator, and this is phenolphthalein. And phenolphthalein is going to tell us, are we acid or are we base? So this is what it's telling you there in your book on page 92. Phenolphthalein, when it's in the presence of an alkaline or a basic solution, is going to turn this really pretty purple color. So underline that in your book. Phenolphthalein is purple in an alkaline solution. So if it's alkaline or base, it's going to be purple, whatever we're testing. If it's clear or colorless, then we are acidic. So phenolphthalein, what's in that little bottle, it's either a blue or brown bottle, is called an indicator. What it's indicating is the pH. Purple for base, clear for acid. All right, now we're going to measure 100 mils. So in your beaker, take the clear bottle with the yellow top and pour 100 mils. This is sodium hydroxide. Pour 100 mils into your beaker. Once you get 100 mils in there, it doesn't have to be perfect, close to 100. Once you get 100 mils in there, take your indicator, your phenolphthalein, and put in 10 drops and see what happens. So we're looking to be clear if we're acid, or purple if we're base. So what are we? We are a base. Purple is a base. So go ahead, get your pH strip out and measure that. Let's see how basic we are. So we've used water, we know that's neutral, and sodium hydroxide is obviously a base because it turned purple. 8 or 9, right? 8 or 9. So under section experiment 3, letter A, it says note the color. Write down purple. Purple means base. And the pH, let's write down 8. So here we are back in that same situation. Our pH is 9 and we can't exist there. That's not good. We can't live. We'd be dead if we had a pH of 9. So we got to neutralize that. So how we're going to do that is we're going to use the lungs to do that. So this is the fun part of the lab. One lucky person in your group gets to blow into the solution. So you have the little bottle with a straw sticking up and one sticking down. And what you're going to do, yes, just like that, you're going to put it, the long end into the beaker. And then one person, while sitting, will blow into the top and make bubbles, just like you're blowing chocolate milk bubbles. So we're using carbon dioxide, we're blowing carbon dioxide into our basic solution. We're pretending we're using the lungs, so we're blowing off CO2.
You want to blow?
Oh, keep going.
Yeah.
You gotta blow for like 2 or 3 minutes. That's why we stay seated, so nobody has to.
Oh my gosh.
Okay,
Wait, you don't have to blow that hard. Just
Blowing that hard.
So okay, like,
Alright, you're doing
so okay, like you're gonna pass out. I was like, I'm not gonna have you pass out.
And what does clear mean? So let's measure the pH of that. Keep going, you're almost there. She says to the pregnant lady.
okay.
Yay.
Protein.
So what did we do here?
Your lungs are
The 6, pH is 6. So what did we do? How did we buffer? We added an acid, CO2 is an acid, so we did the same thing we did with protein acted as an acid. We went from 9 down to 6, so we were using, what we used as a buffer this time was CO2. So we used our lungs, and the lungs are like, whoa, we're in a really acid-based situation. Let's blow off some carbon dioxide and try to get that base from 9 down to 7. So we did a good job, it went down to 6, didn't it? So we used the respiratory system in that equation to buffer. So our lungs are doing that. Either we're going to blow off, we're going to increase respiration and blow off, or if it were the opposite, if we were down here in an
have
acid
it right.
situation, we would
It's
hold on to
slightly
breathing, take
acidic.
slow, shallow breaths, and accumulate CO2, and then
Yep.
neutralize ourselves.
Right at 6.
If, yes, correct. Okay, so we have purple under letter A, and we have pH of 8. Then we neutralized it, or we buffered it with our carbon dioxide. We acted the respiratory system, we went down to 6. And then at the top of page 93, it said, did the solution become more acidic or more alkaline? More acidic, we went from 9 to 6. And why did this happen? CO2, right. So how can we tell it changed pH? What two things?
It turned clear.
It turned clear, so write that down. Color change. And we tested it with our pH, and it went down to 6. So color change and pH first. The next line says, explain why CO2 changes the pH of the solution. CO2 is an acid,
And it gives off a hydrogen atom.
and we
Higher
blew
now.
in that acid into the solution. And that's how we neutralize it. We went from 9 to 6. Then the last question says,